G'day, my name is Josh Wolf. I'm your host for today. We're going to be coding on GitHub Actions and Camunda Cloud. So we're going to start with this Zeebe action that I've created. This is a GitHub action that supports Camunda Cloud operations like publishing messages and creating workflows. And I'm going to extend it to be able to deploy a workflow. So GitHub Actions are kind of small tasks that can be performed inside GitHub workflows. I kind of confused the naming a bit here because you see in my GitHub repo I've got actions, and if I go into actions I can see the actions that run in this this repo, and they are actually created inside .github workflows, and they're YAML specifications of like kind of like a continuous integration system like Travis, or maybe like some of the newer Jenkins X stuff, or what else is there? Circle CI. Bunch of steps that you can run, and they can use little actions. So for example, here's a checkout action that will, basically check my code out. So I've created a Zeebe action that you can consume in other actions, and I'm using this to build an automated kind of build system that's multi-repo on GitHub using GitHub Workflows and Camunda Cloud. So this is the BPMN, the business process model and notation model of my build system. And I'm going to automate this in Camunda Cloud using the Zeebe action. So this scenario is a little complex because I have base images, Docker images, and then I have an API code which then gets built and deployed onto the base image. And then I have a bunch of dependent plugins that then need to be tested against that. So you can change at any of those three layers. We could produce a new base image, in which case we need to trigger a rebuild of the API with the new base image and then trigger the dependent plugins to be retested. Or I could change the API code, in which case we use the existing base image and then trigger the dependent plugins. So those three different layers could be all orchestrated just using straight up GitHub workflows, but I think what I'm out to avoid in this scenario is a lack of visibility of how the whole system works, because where is the single view of how that system is constructed if it's in YAML that's peer-to-peer coupled with other repos, whereas here I get a single overview of the whole thing, and the visibility really, and the comprehensibility of the system, and that also speaks to its ability to be modified. So run it for a while and then go, what, need to change this or that, change it in one place, maybe a couple if I need to, depending on how I crystallize my concerns, separate them. Okay, so here I'm gonna just let's divide this up. So this first kind of process here, I've put all of my processes for the three different kind of concerns in the same diagram just to be able to see them in one place. But as you can see, they have distinct start events. Okay, I think I can go shift and drag. Yep, good. Pull that down. Yes, good, as the emperor would say. Okay, pull that down to there. Good. And logically grouping them to make them kind of comprehensible. These belong together. This is a logical grouping. This is not like visually. It's not like it has no semantic meaning in the execution of the model. It just makes it clearer to interested parties looking at it for the humans. So a lot of BPMN is about making it automated processes comprehensible to humans, because different people need different views. Like system architect or a business analyst doesn't necessarily need to see the YAML in the implementation. We can crystallize this view of the system at this level in the model. Okay, I'll move this up here. Select and drag, put that in the middle. Okay, good. Okay, so the new base images can be built and in Docker Hub. So I'm going to move my builds out of Docker Hub and into GitHub Workflows, because the GitHub Actions and the GitHub Workflows run on Azure infrastructure, and GitHub/Microsoft are pouring a lot of resources into it. So the builds that happen on GitHub are much faster than those that happen on Docker Hub. So that's going to be triggered by a push to the base image repo, which is not actually shown in here. So I'm going to add a section for that. Pull this across. So I push to my base image repo, which triggers. So here we'll say this is git push to base image repo. that's right, I can make it bigger, can't I? Yes, good. This is triggered by git push to base image repo. Yeah, and then so what that will do is that will trigger a rebuild of the images. Rebuild base images. Now once the base images are rebuilt, we should then publish a message. Call it base image rebuild. Now what this base image rebuild will do, so then we're done. Okay, good. So make this into a service task. I guess I'll make this into a service task as well. Okay. This might actually not be this one here. Yeah, okay, so actually no, we should publish a message. It's a command message, really. We'll call it rebuild API. And then what we're going to do here is, yeah, I'm going to put all of the orchestration into the model. A lot of this could be done arguably in one of two different places. Like I could do it in GitHub itself, but then have the question of like, where do I go to look to find it? So I'll make everything in GitHub workflows like super light, just triggering workflows, doing a single thing. So this here is going to be a message that will emit, and this message is going to be called base image rebuilt. So the message now, base image rebuilt, base image rebuilt. Description correlation key. Okay, so what would we call it? We would call it I don't know, build ID. Yeah. When we create an instance of this workflow here, we'll make this into a message start event as well. Yes. Okay, so this image here will be called rebuild base image. Rebuild base images. There's several of them. So rebuild base images. So the way that this is going to work is we'll put a GitHub workflow on the base image repo that on push will publish a message to Camunda Cloud saying the message will be a rebuild base images message, and it'll have a build ID in it. What that will do then is this here will trigger the same repo to rebuild the base images, and in that rebuild base images workflow at the very end will publish a message back to Camunda Cloud, which will then jump into here. It'll be correlated on the build ID, and then that'll publish a message to say rebuild API, which will hit another repo, a different repo. Okay, so the thing about that, do we want to yeah, we'll publish a message. Actually, that won't hit another repo. It'll trigger this workflow here. But one thing about this is it's kind of asynchronous because we're using messaging to communicate back and forth. So I don't get information about a failed build back in here unless I can publish in a build failed message. So one thing that I'll probably want to do here is to deal with the case where something goes wrong and no information comes back, is put this into a sub-process. Put it in a sub-process and put an interrupt, a boundary interrupt timer on it so that it'll raise an incident if it times out. So, think we can do this. Select these, put them in here. Yes, very good. Yeah. Move this to here. Dun, dun. Good. Okay. Now to deal with that case where we didn't hear back in time, that's going to trigger this sub process. Then nicely align. And then we're going to add an interrupting boundary event here. It's a timer event. And it goes to a process out here, which is going to be like our raise incident event. And it's pretty easy to raise an incident. This is kind of like a bit of a hack, really. And what we'll do when we resolve the incident actually is we will then retry. Let's move this to here. So this is the retry. So kind of to give this some semantics, we'll put retry build. And then the way that we can like raise an incident is we go in here and we just say raise incident. Actually, this method's not going to be able to raise an incident twice. So here we make it of type make this type Camunda HTTP. The way that we cause it to fail is we put an input parameter on it that doesn't exist. So we just say the source does not exist. So there's going to be no variable in this workflow will not exist, and then we'll make that target dummy. So it'll raise an incident. It'll say, oh, couldn't do the mapping. There's no required parameter. And then what we'll do on the output parameters is we'll say here, okay, this is good. So we'll map not exist to dummy, which means that actually, this is my hypothesis, we can raise the incident several times because that variable, when we resolve the incident in operate, will set the not exist variable to true, which will then cause it to go through. It'll retry. If it fails again, that not exist that we set in operate will not escape this context. That's my hypothesis. Okay, so once that's done here, that is in fact the end of this process. Okay, so we kick it off with this. So let's start implementing some of this stuff. This is an incoming message that we send in, right? So save this. Okay, let's make this happen. So we're going to use the Zeebe action now to implement it. We go here. The actions thing. What do we got open? File stuff, file, new window. I'm going to open my base images repository, and I'm using here my Magic Craft, so it's Minecraft base images. So I'm using as my test kind of domain. So it's in here and it's in Minecraft, and that's it. Yeah. Oh, okay, so yeah, the way I did this is I put them into different branches. Okay, the reason that I did that is because on Docker Hub I can set up the automated builds. Well, let's just do it with one branch, okay, to start with. So we'll work on the master branch. So we're in the master branch now. And then what we do here is we create a new folder. Well, let's do it on GitHub because it's easier to do there. So if I go to, these ones are stored at github.com/magicraft/Minecraft. Default branch is master, so we're on there now. Okay. Okay, so we go to actions in the repo. And then in here, get started with GitHub Actions. Now the action that we want to do is on a repository push, we just want to publish a message. That's the first thing. So is there one here that looks like it could be good? Automate every step, labeler, stale, blah, 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 publish. Well, let's start up by build a Docker image to deploy or push to the registry. Docker file. There's a couple of different Docker ones in here, I think. There's that one. H from Silk Music. Okay, well, let's just use it. Let's just do it. Set up this workflow. It's going to create the folder, create the Docker image. Okay, checks it out. And then it's going to build the Docker image, right? Docker image on push. So we are going to use this, but we're going to do this on a repository dispatch event. And then we should get the name from branch. Well, let's have a look at what it's set at the moment, or what it's set it to. Log file. Let's just use anything. Let's say Minecraft to begin with. And then the tag, I want to tag with latest, but it's also paper, and it's using GraalVM. So this is paper, but which paper? I think this is paper 1.14. Block by changing to paper 1.14. Nope, that's 243. So this must be paper 115.9. Yeah. Okay. That's paper 115 Graal. Okay, so check what I've named them on Docker Hub, because we're going to be replacing Docker Hub, so we want it to be exactly the same. It's hub.docker.com, and this is a MagicCraft /Minecraft. These images are called. There we go. Last updated 9 days ago. Tags. Here's the tag for this one. This one here, that's the tag we want to build. Send. Nope, start from this end. Annoying. Copy. Let's try that. Back to GitHub. Here. Okay, and then we'll put the full tag is MagicCraft Minecraft, and we push it to Docker Hub and on there. Okay, so the part we're looking at here is what's going to get triggered in the model here. We build the base image, publish to Docker Hub. Okay, we're not going to deal with detecting and handling failures just yet, and leave that out of scope. We'll just do the happy path first. Okay, I'll save that to make sure I don't lose it. It's going to come in here, so we need to do that, and then we need to publish it. Now, I am publishing Docker images from another GitHub workflow. Where is that one? I think in the Zeebe CTL one, I've got it set up in there. So if I go jwolf/Zeebe CTL, look. Yeah, okay. Go to code. GitHub workflows, release. So when I cut a release here on a release tag, bam, does this. Here we go. Publish Docker image to registry. Let's grab that. Copy. Paste. That out. Okay. Too helpful. Like, hey, goodness. Dude, that's not what I want. Okay, use the keyboard. Okay, what's the problem here? Bad indentation of mapping entry. Okay, so we need to go Shift Tab. Okay. Oh, okay, so. Oh yeah, that's pretty cool. Okay, in that case, I don't need this whole build thing here. Let's do. Okay, here we go. Generalize it a bit later for the different branches, or I might have to move them out of branches into different folders and then do this. You can do what's called a matrix build. So I can do a matrix build, and then I'll do it. And then I'll put them into subfolders with these names, and then just put the names in. So that's pretty cool how you can do that. Okay. So hard code the tag to start with. In which case we can just get rid of this. I'm not going to use that one. I'm going to use this one. Okay, and then as you can see here, I need to put my Docker username and password into the repo. We'll start the commit on that. So that creates the Docker image. Now, that gets triggered on repository push, which is this. This does a repository push. What we need to do is create this workflow, an instance of this workflow, by sending a message on push to here. So let's create a new file in here then. Create new file. And we'll just call it on push.yaml. Okay. If we go here and then I just pull down the latest changes from GitHub, I'll be able to see them show up here. There we go, GitHub. Okay, so we'll start with this. Paste that into there. Okay, so this one here is, we'll call this one kick off. What do we call it? Automated build? Orchestrated build. Build orchestration. Okay, so this one is on push. And it should only be on push to one particular branch, so here we can go push, okay, branches, I think, I'm guessing, that's his tags, right? So on push, so I reckon if we go branches, and then so it's only going to push to master. Now this is not a build, this one is a commit, no, start workflow. Okay. Yeah, very good. So now we're going to use the Zeebe action, right? Let's go down to the Zeebe action. Okay, so we'll copy this. And you know what? We don't even need to check anything out. But we do need to create some more secrets to connect to the Camunda Cloud cluster, right? Now, operation. So this is not, this operation is publish message. There's three operations that it currently supports. So for the publish message operation, you got message name. Oh, okay, no, this is a problem. There's a limitation that you can't actually pass variables in, and we need to pass in the build ID to get correlation. Oh no, we can't correlate any messages. Or can we? No, we can't. Okay, problematic. Oh. Zeebe-io. So this is the Zeebe HTTP worker that runs in Camunda Cloud. There's a limitation at the moment. If we go into the issues, I opened this yesterday, where configuration keys overwrite each other. The bottom line is that to create a message publishing task using this GitHub action, you can either specialize the task in the model, but send no variables in the message, or else you have to put the message name in the variable payload, which is pretty useless. Yeah. Yeah, no, that's not good at all. I mean, yeah, okay, we could work around it because we started this by I published the message back in here. No, okay, so yeah, okay, no, I can. So because we're starting with a publish, then we should change this to just a standard start event and start the process by name. And it just need to make sure there are no other. Yep, okay. There are no other. Okay, in the meantime, we should actually have this not run. Okay, we'll start the process by name. So this process is going to be called, call it Magic Craft GitHub Build. Okay, so we now change to, let's change this back to create workflow instance. No IntelliSense in here. Let me just check if it is called, it's called Operation Create Workflow Instance, yeah. Okay, so create workflow instance and then BPMN process ID. And then process ID, put my BPMN process ID in, and then the variables, we need to give it a build ID. Now if we go back to DBCTL, that's it, and here it has published a Docker image. Registry, nope. Okay, it was in GitHub Actions. What I'm trying to do here is get a unique ID for this thing. I guess we could use the GitHub hash, right? Commit hash, that's a unique ID that we know for this. So GitHub commit hash plus the time, because we might rerun the same actions context. So inside your GitHub action, you have access to a different contexts, and one of them is the GitHub context. And the GitHub context gives you an object which has a bunch of things on it, which includes things like a commit hash. Okay, GitHub event run number repository event name char. So if we use the github.char, go back to here. GitHub context is just the GitHub char, and then we should append to that a unique ID. I think if we just do date, no, time. Should work. Build ID, we're sending it in with a build ID. We're going to start an instance of this workflow. Okay, kick off the build orchestration. Yep, so what that does is it creates a workflow instance of this workflow here, starting from here. And then we'll say, this is like start rebuild. And then if it doesn't succeed within, I don't know what, we'll give it 5 minutes to time out. Limit definition type duration PT5M. PT5M. I'm never sure about that, whether it's months or not. So 5 times 60 is 300 seconds. Yeah, 5 minutes. So wait 5 minutes. Time out after 5 minutes. Time out after 5 minutes. Okay. Yep. Okay, good. One here gets triggered. Yeah, we'll do the triggering of that one in a second. So let's go back here. So kick off build orchestration and branch as master. So commit that. So when we push the base image repo, it'll run this workflow, which will create an instance of this. It will then start the rebuild, and it needs to trigger this. Okay, so first things first, we'll do the secrets first, okay? So I've got to put my Camunda Cloud console secrets in here for a client. So I go into secrets and my Docker Hub secrets to publish the image. Okay, so Zeebe address. So these credentials I get from the Camunda Cloud console. So I go to camunda.io, console.cloud.camunda.io. It's gonna log me in, etc., etc. I'm not actually running it on that cluster. I'm running it on a different one. I'm running it on this cluster. I should delete that and change. I don't think you can change the name of the cluster. No, I can't. Bummer. Anyway, I'm linking everything onto this one, for better or for worse. So here's my clients, and then when I click show connection info, I'm going to get the details that I need, right? But what I'm going to do is I'm going to just blank my screen while I do that, because obviously, oh, here's one that says delete. So if I click on show connection info, it gives you a bunch of these things. Here's Zeebe address, so you grab that, stick that into that secret, create a secret with Zeebe client ID, etc., for each of these things here. Delete that client, since I just leaked credentials to the internet. Delete. Okay, here are my clients. So I'm going to grab my actual secrets. Okay, so this. So I'm grabbing my Zeebe address credential, secrets, Zeebe address, paste the value in here, add secret, next secret, Zeebe client ID. So I grab my Zeebe client ID, C, and add a new secret, Zeebe client ID, grab the value. You put them in with no quotes, just in line. I'll show you that in a second, just to make sure that you know which pieces you're copying and pasting. Now the Zeebe client secret, grab that. Let's add a new secret. I remember reading about these theoretical attacks where they could detect people's passwords from the sound of them typing on key locations, but I guess that would only really work against QWERTY layouts. Luckily I use Helmac, so they would have insufficient data about delays between typing on keys. See. Okay, yeah, this is not a secret, so I'll show you this one. So the name and the value, just paste the value that's in the quotes on Camunda Cloud, just straight in there, add the secret. There we go. I got Zeebe address, authorization, server URL, client ID, and client secret. So now I'm going to add my Docker username and Docker password so that it can publish to Docker. Docker username. Cedar Putty, that's not a secret, so that's where all my images are. What is a secret, however, is my Docker password. Not even I know my Docker password. That's how secret it is. I use a password manager and it's like a super secure string kind of thing. Okay, so Docker password. Now to get my password, I go here and I go here. Copy the password, and because I am going to paste it and it'll be in clear text, I'll just block my screen for a second. Paste, add the secret. Okay, so here is the complete collection of secrets that I need. I need my Camunda Cloud credentials for the client to be able to communicate with Camunda Cloud, and I need my Docker details to publish to Docker Hub. Okay, secrets are in place. Let's go back to the code. So we've got two workflows now. Let's pull down the changes here. So we can look at them here. So we've got the Docker image. So this one's really Docker image CI. So let's change the name of this to publish Docker image. And it will eventually be published Docker images. Docker images, we'll use a matrix build. So build. It's actually build and publish. So we'll say build and publish. When you have matrix builds, they fail fast. So the first one of the matrix that fails, it'll fail like all of them. Right. Okay, so here we go. Looking good, looking good. also rename, I don't know, what did we rename this task? The job, publish job. Rename publish job. We're going to skip to the next song because not much talking in this one. Let's actually change to Taking You Higher. Oh, what a great mix. Taking You Higher. Progressive house mix. So this one. Play. This one, number 3. Starts with Inner Space by, I think, Gregory Essayan. Okay, we've done that. Do we want to test if it works yet? I guess we kind of should, right? Let's go back to the beginning of this. Now, I think we probably should test if it works. But now, what it's going to do when it does work is it's going to execute the first part of this. Oh, hang on. We need to publish this message out at the end of here. Let's do that. Okay, so after we've done this, we now need to publish the message back to Camunda Cloud to have it continue the flow. So, users, name. Tell Camunda Cloud what's up. What's up? Okay, so users. So the Zeebe action is JWULF. That's my GitHub username. / Zeebe action. Zeebe action, and I'm just like, for better or for worse, running off master right now. I'll keep backwards compatibility. And then here we say with, and these are the parameters that passed into this action. So the first one that we need is operation. So this operation is publish message, one of the 2 operations it supports right now. There's publish message, create workflow instance, and create workflow instance with result. Okay, and it needs a message name, right? It needs a message name, and the message name is, let's go back to our model here, built base image rebuilt. So we publish this message, base image rebuilt. Base image rebuilt. And then we need to pass in some variables, right? Because we've got to correlate it with the running instance. Okay, I'm thinking to myself here because we need to pass back the build ID. We need to get the build ID, right? Okay, build ID. Now the value for the build ID is gonna be, first of all, quoted because it needs to be JSON, right? String, yeah, okay, so it's good. So the build ID, we're gonna get the build ID from the GitHub.event, GitHub context, the event. Now on this event, for the repository dispatch, which I think is how this gets triggered, yeah. The repository dispatch event has what's called client payload. And this is like arbitrary data that you can pass in, and it will be .build ID. So we just got to make sure that when we send this repository dispatch, we pass in the build ID. And it turns out that is it a publish message? No, yeah, it should be fine. We can do it. Okay, so I think that's all we need. That's it. So then I'll trigger this. Now, it's the implementation of this. So when this gets created, which gets created from the on-push workflow. What's wrong with that? Oh. Something's not right about this. What doesn't it like? Let's have a look at a repository where I have one that I know works, right? Here we go. Here. That. Listen to here. Okay. PMN _process_ID. That's right. In YAML, you don't use these camel casing, you use snake case. But what doesn't it like about that? Is it the minus? Does it? No, because the other one has a minus in it. Put that down. Okay. Put that down. Okay, operation with. Okay, with. Yep, operation, yeah. Workflow instance. Just something about the variables. Looks good to me. What doesn't it like about this? Multi-line key may not be an implicit key. Bad indentation of a mapping entry. Let's have another look. Name users. Name users. Name. Ha! Cannot read a block mapping entry. A multi-line key may not be an implicit key. We need to change the name of the BPMN process ID. Same problem here. What happens if we make that comment? What happens if we make that a comment? Nope. That. Okay. I don't know. Maybe is the syntax highlighting wrong? No, it's the children that are wrong. Okay, steps. I think this is not indented correctly here. Yep, that's it. Okay, so let's just Control Z our way back to glory. Like that. Okay, the problem is actually there. No, still not buying it. Look, runs on, yeah. Start workflow, runs on Ubuntu latest, and it has steps, and the steps are indented, yep. And then it's got name, it's got users name, yep, users, okay. Name users with, name users with. These are all indented like that. These are all indented like that. I'm just gonna save it and see what happens. Update. I don't even know what I did in that modification, but let's just do it. Okay, we'll stick it up there and see if it runs. So, if I push there, it's going to start an instance of this. Start the rebuild, and then we need to implement this here. So this is going to call out to GitHub. So we use the Camunda HTTP worker. Keep rolling with this. And then we'll just say trigger rebuild. ID must not contain spaces. Trigger rebuild task. Nice. Save that. Okay, so input parameters. It's going to pass on all of the variables. No, actually, yeah. No, we do need to map some parameters in here. To see how this one works, where have I documented this? A repository dispatch event. How did we get it to do a repository dispatch event? Oh yeah, that's right. I have another model that shows how to do that. So my GitHub CC. So there's quite a bit of kind of wiring that you have to do at the moment. I mean, it'd be great to elevate all this to first class, right? So it's like first class GitHub integration. Test repository dispatch, this one. Here we go, send a repository dispatch event. Come on to HTTP. Oh yeah, okay. Authorization. Yeah, I gotta get my GitHub token in there as well. Okay, a bunch of things you gotta do. system, so authorization. So we're going to map authorization onto authorization. Actually, we'll map GitHub token onto authorization here. Okay, that's good. It needs a GitHub token to be able to do the thing. Okay, URL and method. Okay, so go to headers and then method is post. So we're going to post to the GitHub API. Post. And then the URL that we're posting to is going to be the URL of this repository's dispatch endpoint. Which is, if we go in here, I'm just going to grab this whole thing. Control C that, go back here, Control V it in. Now this is pretty small and I apologize for this, can't really blow this up much more, but you've got repo org and repo name dispatches. Should I keep it generic like that? Might as well, hey? Then I'd have to pass them as variables, they get templated in. I'll just hard code it for now, just to make it a bit easier. There's enough abstractions in here as it stands now. So it's repos slash my repos jwolf, this is the repo that we're going to tell to rebuild. Jwolf / no, it's magicraft / Minecraft batches. Put output. It's going to put the GitHub token into the authorization, so we need to make sure we pass it in at the very beginning. Okay, that looks good. So this is necessary and sufficient to trigger that. Save that. Go back to here. Now, when we trigger the workflow, which is in the on push, not only do we need to pass in this build ID, we also need to pass in GitHub token, right? Now, we're not going to actually pass in a real GitHub token. We're going to tell it where to get the GitHub token from. Where it's going to get the GitHub token from is it's going to get it not from this environment, it's going to get it from the worker variables in Camunda Cloud GitHub token. So where that comes from is if you go into Camunda Cloud, oh, okay, I'm going to have to change my deets now. Bummer. There's no way to hide them. Huh. I wonder if I can go back and edit the archive video to blur that out. Might be able to do that. I think I can actually. Yeah, I'll probably do that. Easier than me changing all these dates. But yeah, you go into here and you click on worker variables. Let's try it with a different cluster, so that I'm not leaking more and more. DB cluster is not MGK, but there's another one. Try reloading the page, and it should have my GitHub Actions cluster up here. So I go in here, and then I click on worker variables. So in here I can add my GitHub add variable. Okay, it's a bit deceptive there. You add a GitHub token like this, and then you paste your GitHub token into here, which you're going to get from your developer page. So if you go into here and you click on settings, make any variables, I think, and then you click on developer settings, personal access tokens, and then you generate a new token. So I've got my Camunda Cloud token here, and you got to give it the repo scope. Okay, I've done that. So this tells the Camunda engine, the Zeebe engine, to template in the worker variable for GitHub token into this thing here. Okay, so save that, and then let's add GitHub token, I guess. What I did, add GitHub token. Push that, and push. Since I'm pushing to master, it'll actually be trying to run these things. Add indentation. Okay, so this looks like where my problem is here. So in the Zeebe CTL one, we got push. Add. Okay. So you got to do it like this. By the look of it. which is kind of good news because it means that this thing hasn't been running every time. Well, it wouldn't be running anyway because I haven't deployed the process yet. Like this. Okay, of course this is going to be a an array. We look at it. Oh, okay. Like this. That. It's gotten rid of that error message there, so fix on syntax, I guess. Syntax. Push. In fact, if we go into actions here, we can see that there's a lot of failed actions for these different pushes that I've been doing. Invalid workflow file, yeah. Okay, YAML syntax on line 3. So that should now be fixed, actually. So the latest one, yeah, there you go. See, it's correctly parsed it, but it's failed in some way. Let's have a look. What failed? The workflow file was invalid. Unrecognized name value time. Yeah, okay. Did have a concern about that. The quickest way to get this is just the GitHub Action time. Oh, it's an action. Huh. Current time JavaScript action. Sure, why not? Let's do this. Grab it as a step. And it's going in here, so we add this as another step. Okay, so indentation. So you can get the outputs from named steps, right? Which is what we're doing here. We're going to grab, just whack it in here. There you go. Get rid of this. Ta-da! So you know, you give the step an ID here, and I'm not sure how this gets into the output. In the code for the action, actually, if we go into the source code for this thing, so you can use this great TypeScript Actions core, and what Actions core does is it gives you things where you can do like for get input to get inputs from the YAML file, and then you can also do set output. I do it in here anywhere. There we go, set output. So you can get the output by name from the previous step. Okay, so we'll get the current time. Now this should fail. Does it fail? Well, let's see, because it's going to say I can't find a Magicraft GitHub build process. It's going to try to connect to the Camunda Cloud cluster. This will be a good test. So fix time step. Fix time. Variable. I don't know. Whatever. Push. Okay, so now we will see our action run, and it will try to connect. It will connect to Camunda Cloud and try to start the workflow. It'll be interesting to see how it deals with that. I push. It's still pushing. Okay, it pushed. Okay, great. So it's pretty responsive. Like, you know, it kicks that job off straight away. It's not like Jenkins where you're like waiting. Your job has been queued. I mean, look, it is queued, but it doesn't get queued for long. Get the current time. Okay, so there's a problem with the action. Oh my goodness. Okay, so this problem here is caused by, you know, the communication between the client and the broker with Zeebe, and obviously the Camunda Cloud, which is hosted Zeebe. It is over gRPC, and the gRPC core libraries for pretty much all languages are implemented in C++. There is a JS version. Maybe I could use the pure JS version, but I'm not going to try that now. That's like really chasing a shiny thing at the moment. But so yeah, the Zeebe node client library uses the C++ one. Now when you create an action, everything gets bundled up. It's kind of like Webpack. It gets bundled into a single index file, and then, you know, now we got like what are these things called, binary dependencies that we need to make sure are in there. So to build this action was actually a little complex because I'm on a Mac, and when it runs on GitHub, it's running inside Ubuntu. So I needed to build a Docker Compose to do the building, and then like a build script. So let's go and fix that up. Let's find out what's wrong with it. So it's in the Zeebe action. Hey, this is why you need to have tests, so that you don't break this kind of stuff, and then a stable release. So once I get this fixed, I'll make a stable release for people to rely on so that I don't break it incidentally. Now, it's in the dist folder. Yep, here's this here. Okay. Okay, index. So I did fix this. .proto. Yep, so it's going to go up one. It's going to grab this proto here, the Zeebe protocol file. Now, why would it not have the binary that it needs? Look, my build script, which copies in the protocol file, and then it also has to change the path because the protocol file in the normally installed npm package for Zeebe node is in one place, but when you webpack it up like this, it uses ncc, which is like a kind of bundler from Zeit. Remove this, yep, replace it with the patch version. Okay, well, I'm gonna run my, so in the package.json, I have this rebuild, which does npm install rebuild. No, okay, hang on, just think this through for a second. npm install rebuild. npm install, it's going to do a rebuild of all that stuff, but somewhere I have a Docker Compose command, npm run build, tsc, npm run format, lint, pack, test, what? Weird. Working directory there, Docker Compose, npm run rebuild. It's funny because, yeah, man. It's what happens when you work like for a long time and you solve a problem, and then you're like, what happened? Somehow I did Docker Compose up build. Actually, no, I gotta start Docker. Okay. Docker Compose up runs npm run rebuild. Okay, so if I go here, it runs this. Right, okay, it runs this inside the Docker container, so it uses the Linux bindings to build a Linux output. So this should never be run. I should do this, underscore rebuild, right? Make this clear what's going on. Man. Do that. And then in my package JSON, I go rebuild. And then what rebuild actually does is it does this. It does Docker Compose up. Minus build. This, to figure out how to do this, to get like a cross-compilation kind of build system happening on my local machine, was like, guess I could put it in the GitHub action that when I push, it'll rebuild it and then check the rebuilt thing back in. Yeah. Whatever. Okay, let's try it again. So if I now say npm run rebuild, okay, building the builder. So it's building the builder container. which is based on stretch, so Debian, node 12, because yeah, it seems to be running node 12 in the GitHub Action. Okay, it's building the builder. What does it need to build about that builder? Not a whole lot. Anyway, it is doing its thing. There we go. Recreating, attaching. Now it runs npm install in there, so it's going to pull down tons of packages from the internet. Well, I wonder if it does, or if it just parses the... I think if you do double minus rebuild... I'm not sure. I'm not going to make anything up. I'm not going to make it up. Okay, parse the dependencies. So it's onto TSC, which happens... npm run build, so that's there. It's building the TypeScript, formats it, lints it, and then npm run pack, so that's where it runs this ncc thing, which does like the web packing, and that puts it into this dist folder here. And after it does that, it runs the tests, and then it runs my build script, which does a little bit of kind of manual manipulation that I needed to do to get Zeebe node to run in a GitHub action. Compiling file index.js, so that's the mash down. It contains all the code, including all of the dependencies for this this action in a single file. And then I wonder if the source node extension binary will be will disappear once it's done. And then the main in here is in lib main.js. This. Okay. That's my actual code. Okay, so it doesn't actually... I think then this dist index must contain just the dependencies. Like there's the code for the Zeebe node client right here. This must be all dependencies. Okay. Yeah, exit with code 0, good. In my build script here, I should say that that I'm doing something. Echo, just and this acts as a comment as well as an inform at runtime. So patching, so we're going to patch dist index.js for relative protocol file, path to protocol, Zeebe protocol file. In GitHub Action. Okay, what changed? Let's have a look. I updated that, updated that, updated that. Something changed in here. Okay, look at that. Binary.find path resolve path join is what it said before. Now what it says is source node extension binary node, etc., etc. So that looks like it'll work this time. Fingers crossed. So now what we want to say about this is rebuild binary depth, I guess. I mean, entirely possible that what happened is before I checked in, I didn't run this, so I should automate this because, goodness. Dude, let's make a note to myself in here. Development, run the npm run rebuild task before checking in. And then really I should put it in Husky and make it a pre-commit hook. But we're not going to do that right now. Update, readme. Okay. Alright. So we'll push that. And then now, if we go back to here, then I can say rerun the jobs, rerun all the jobs. And this should pull the latest version of that GitHub action from the master branch of that other repo. Echoed out the time to see what it looks like actually, but we'll get to see it. Will we? I don't know. We'll see. We'll see. I think we will actually. And here in the create Zeebe workflow. Ta-da! So there you go. Command rejected with code create. Expected to find the workflow definition, process ID, magic craft, GitHub build, but none found. So the next step is for us to deploy this process to okay. Let's just make sure that this is that it won't reject on deployment because it has missing, syntax or like structural. So this thing is rebuild API. This is a command. And this here, no message details. Okay, so here, this message is called rebuild API. Yeah, these don't have task types on them. Gosh, for the completeness of this model, I need to do all of the pieces. So I might copy out what I've got so far and stick that somewhere else into a new model that we deploy. So we can do it piece by piece, right? This doesn't have a task type on it either. This will make it simple, just do a get to google.com. HTTPS google.com, that's down, the internet is down, plus, and then we make the method a get. Get. We'll create a new BPMN diagram and we're going to copy and paste this thing over. Just gradually build it up. Yep, okay. So this one, we want to issue the command to rebuild the API, publish a message. Okay, yeah, so this is a Camunda HTTP. I'll do this first, then we'll deploy it, right? Camunda HTTP, and headers, we add a header and we call the key body. This is the name of the message that we're going to publish, right? So we make the value like this. Event name. Let's consult the documentation. So in order to affect this publishing from here, we've got to use another it's another GitHub action actually. No, it's not even an action, it's a workflow that uses the action. So this one's called the Camunda Cloud Publisher, right? And all you need to do to get this to work is fork this repository. Camunda Cloud message publish. All you got to do is fork this repository into your into your GitHub account, and then you've got a cloud publisher. Okay, here we go. We set it up like this. Okay, we've got to put this into the custom header. This. That shouldn't be there. But anyway, let's do this. Okay, so specific message name that we want to publish is rebuild API, right? So here we say rebuild API. And publish a message called rebuild API. Actually, goodness, should say rebuild Magic Craft API, because if I want to do any more of these, I need to make them namespace. And then headers, so custom headers, the URL. And the URL will be, grab my URL in here and then it's a post. Tell the GitHub workflow in here to dispatch it, and then it will publish a message back. Method post. Okay, so we've got a new diagram there, but what we'll do to get this into the new diagram is we'll just grab this whole thing here, Control C, and then Control V. Beautiful, beautiful. Whoa. That was a new behavior that they made, you know, when you paste, that you get the opportunity to choose where it's going to drop. The Camunda modeler guys. Killer. Okay, so in the properties panel, we're going to change this to be Magic Craft something. Build automation. Put from here. Magic Craft GitHub build. So it's going to publish this message, and then what we'll do now is we're going to drop this message in here, message start event, and then have it do what? Throw an exception, I guess, just so that we can see it, that it came in. So here, this is rebuild Magic Craft API. Rebuild underscore Magic Craft underscore API. Yep. Just copy that name from here to here. Make this one service task. So just throw incident, raise incident. Oh, so many things that can go wrong along the way here, hey? But let's just apart from the wiring itself. But let's just do this. Okay, so in the input output we just do input parameters, and we're going to do again like the not exists to dummy. Not exists. Target value is dummy. And then that'll throw. And just add a little note here to always throws. Always raises incident, and then we can just cancel this. This will be a new instance of the workflow. Okay, so if I now save this, save file as, let's put it in here. This is in GitHub underscore CC. Make it. Give it the same name because it makes it easier to find stuff when they've all got the same dates. Okay, so if I go to now my GitHub CC here, okay, so I now need to deploy this to my cluster. So if I grab a new terminal, Zeebe CTL, I don't know if it's got the credentials in the environment, but we shall see. So deploy bpmn/magicraft. Let's see if it's got, nope, it doesn't. Okay, so to get that to work, all I need to do is go to my Camunda Cloud console and get my client credential thing. The clusters, MGK, on here. I'll show you this whole thing. So create a new client, and we'll call this one delete, because I'll delete it when this is finished. Add this. Go down here. Oh, there it is, delete. Copy the details. And then I just literally just paste it in like that. So good. Double up and then hit enter, and it's going to deploy. Hey, yeah. What didn't it like? Okay, there's no message reference in there. Oh, did it lose the message definitions? It did. Just make a note in here that it's emitted in GitHub workflow. So we know where it comes from. So nice. This. And because it's ruined the symmetry of this part here, we'll just fix that. Okay. Needs to be resolved. By setting, what do you need to set? Let's have a look. We go in here, the input output not underscore exist. And then we should change that semantically to be like incident resolved. We'll say in operate, because that's where you're going to have to do it. Operate. Okay, it looks good so far. Okay, so there's this one here, it has a message. This one has a message. Yep, it's looking good. One last thing, just to finesse this a little bit more, because there. And this is rebuild base images on push and git push. Git, so just like git push master. Make that bigger. Can I change that? I can move it. That's pretty cool. Just put that there like that. Okay. That looks symmetrical, but whatever. Save it. Redeploy. I raised an issue actually to get rid of that help output when there's an error that's not like you typed the wrong thing, but something else. If we go to the Minecraft repository now, Magicraft Minecraft. Is that in here? That's in here. So if we go to actions, we should see the on push or kick off orchestration. 11 minutes ago, 25 minutes ago. Oh no, we deployed it. Okay, so now having deployed it, to kick off the thing, we need to push to this repository. Kick it off. So if I go to my Minecraft in here, let's make add a couple of blank lines, and then we'll just say add blank lines. Add blank lines. Save that. Commit that. Push that. Now, when we push it, it'll kick off in this repository the kickoff build orchestration workflow, which then the only thing that does is creates a workflow instance on Camunda Cloud. Start workflow. Obviously, you're not going to use this for like hyper low latency stuff, but this is orchestration. So there you go. It's created an instance of it. Now, if we go here, And then we open the operate instance on Camunda Cloud. What do we see? Okay, a couple of instances. Here we go. This is the one we're looking for. Let's get rid of this just to clean things up. So cancel that instance, go back to the dashboard. Magicraft GitHub build has an incident. Okay, it came in and then it just bombed out right at this point here. Okay, well we got the first part working. A git push to the repository now triggers a workflow on Camunda Cloud. Now if we go into the incidents view, we'll be able to see what went wrong. Incidents. Oh yeah, click instance ID has an incident, drop this down, get information. Okay, so I've got a 404. Okay, so a couple of reasons why I could get a 404. It's either the URL is incorrect. Well, let's have a look at this. So it's either the URL, repos, Magicraft, Minecraft, dispatches. I think that is, I think that's good. And the only other thing that it can be is this here, GitHub token into authorization. I know what it is. Yep, I know what it is. I know what it is. We go into on push, and here, this actually needs to be set to Vera. This is in the documentation, but I keep forgetting that. You got to do that. Actually, you know what? I wonder if we could do it in the modeler. So if I go here, where it says, no, it's only mappings. I can't map in a string. Yeah, so I actually have to pass that in like this. So you got to pass in bearer and then the token, like that. Okay, but the good news is that when I push this, it will trigger another instance. So fix GitHub auth token format. Yes. Push. Okay, it's pushing. So go back to the dashboard. Go back to the actions. Now we should have one that says, go into this. GitHub auth token format. Yep. It's running the workflow on GitHub. Yeah, these things just start straight up, and they're pretty fast. There we go. It started a new instance, right? If we go here and then on this. This is the one that we looked at before, so we're going to cancel that to get rid of it. So if we go back here and look at actions, again, we should see that ran. Yep. Go back to operate. Okay, it looks like there's a new incident. Go back to the dashboard. 422. Invalid request failed with 422 message, invalid schema. Okay, so the repository dispatch event that I sent through doesn't have the right format. More. Nil is not an object. Okay, so repository dispatch needs some object to be passed in with it. Or client payload. And push, it comes in here, and we need to put the build ID in there. Okay. So this one here, this is the one that's pushing, input output, headers. Okay, so what we need to do is we need to pass in the build ID that we got in the initial kickoff. So the source is the build ID, and that needs to go into body dot client payload dot build ID. And let's have a look at this test repository dispatch, how I did the mappings in here. That was my original test that does work. Body client payload tag, body event type. You need to have an event type, that's right. Well, we know we have a build ID, right? So let's go build ID and put that into the event type, because we're not switching on event types here. Body.event type. So target is body.event underscore type, I think. Let's go back and check. Body.event underscore type. Yep. Okay, save that. So clean up. Cancel this instance. Go back to the dashboard. Go back to GitHub CC. Redeploy the new version, or deploy the new version of the workflow. Yep. Okay, we'll go back to here. Can I rerun a successful job? Negative, you cannot. I need to do another push to this repo to kick it off then. Let's create a new workflow, or yeah, okay, it's a completely new workflow. Okay, so the Minecraft repository, the one that we're going to trigger on git push. So if we go to the README, I added a couple of extra lines. We'll just take them off. So remove lines, commit and push. Go back to GitHub, and we will see it kick off another build orchestration. Confident that this first part's going to work this time. It's worked the last 2 times, and I don't think I changed anything related to that. So here we go. It's kicking off the build orchestration. The workflow. See how fast that is? I mean, it's like GitHub downloading to GitHub, right? So it's going to be fast. Okay, started a new instance. This. No data found for query build ID. Okay, I think I must have mistakenly in one of my mappings put build ID. Input output mappings. Right there. Okay, save that. Now let's just go back here and validate that it does have a build ID in it. It does. There's the build ID, so that's the GitHub SHA, and then there's the time from that step. And then you can see here my authorization header, which we know is working now because the API responded that, hey, the format of the object is wrong. But you don't get to see the secret in Operate, which is pretty cool, The worker replaces it at runtime. So it's actually not the engine that replaces it, it's the worker that replaces it at runtime. Okay, let's have a look. Okay, so we'll cancel this instance. It's a new version of the workflow that's necessary, so deploy the new version of the workflow with the fixed input output thing, version 3. Almost version 2. Okay, we're in the clear. So now what we need to do is again do a push from here. Gosh. Save that, add lines again. No, this one's called blurred lines. And push. Actions. Second. This is not dynamic, so it doesn't like no WebSocket or polling or anything like that. You have to refresh the page. Pretty much 99.9% certain that this will work. I mean, this part of the flow. It's a Zeebe workflow. It's done. Go to Camunda operate. Okay, failed to extract the correlation key by base image rebuilt. Okay, let's have a look. Good. So if we go back here, what we'll find, well, that's interesting. I would not have expected it to have completed that fast. Publish Docker images. So it's published the message already, even though it hasn't built yet. not even finished, it's still running. But see how fast this is? Like, this thing is fast. It's doing a Docker build. I mean, Docker Hub would not have even started the job by now. Publishing, so it's building. It's building, and then it's going to publish. But okay, it hasn't got to this action here which publishes, but Camunda operator is telling me that it got a message. Oh no, okay. Yeah, okay, the correlation key could not be extracted from the payload. So what that means is, if I have a look, dude, that's what's up with that. Yeah, okay. I pasted that in the wrong place. Save that. We're gonna have to do this again. So deploy version 4 of the process. Let's see how that job is progressing. What happened? I'm not a happy camper. I connect to Camunda Cloud. Wide configuration not found. Okay, so what I've done wrong there is if I go to my Minecraft here and to the workflow for image. Yeah, okay, it's missing all of its credentials, dude. Missing all this block here. Okay. Save that. Okay, I saved it. Now, one thing about that is I would have expected this when it got this error. Ah, okay. Oh, this is a problem. I'm not going to exit because the cancel the workflow because the Zeebe client is holding it open. So if I go to my Zeebe action, let's have a look at where this gets parsed. It's in main.ts and it's right here. It comes in, it does this here. Okay, but it should exit here. Okay, yeah, so we should actually here return from this statement. It's the easiest way. We're done. Yeah. Okay, and then I need to do my npm run rebuild to rebuild this whole thing. I wonder if I could just do tsc if that would do it. Let's have a look at the ts config. Yeah, okay, TSC is actually all I needed to run there. Because I'm not changing any of the bundled stuff. So if I run TSC, it should update lib main.js. And then exit on configuration failure. Lib. Why did that not rebuild it? Lib main.js should have rebuilt that thing. Are you telling me that lib is get ignored? No. Is that what it is? Did anything get ignored? Yeah. Node modules, yeah, a bunch of stuff. Lib coverage. Okay, too much to parse. Let's just search for it. 3. Lib coverage, and lib. Ignore built TS files. Okay, so it must build it in lib, and then it must build it in lib, and then copy it into the package. That NCC thing must do it. There must be an NCC config in here somewhere. suggest action. Where's the configuration for the NCC bundler? Maybe the NCC bundler just parses this, finds this main entry point, and then bundles it from there. Yeah, that must be it. Must like resolve the dependency tree by loading that file and parsing it. Okay, so I've got to rebuild the whole thing. Regardless of that, I think that's a convenience action, right? Now we go back here. If I now push Minecraft here where I added the credentials in now, so I have the credentials. So add Zeebe credentials. Okay, so add the Zeebe credentials and then push. The thing about this YAML is that it can tell me about some like the kind of the structure of it, but can't tell me about like syntax, like semantics. It can tell me syntax. I don't know. Semantically, it can't parse this and say, hey, JWolf Zeebe Action actually requires these things to operate. If you have a look at the Zeebe Action itself, it has an action.yaml, which actually is a schema for what's required. And like these things are required properties. However, when I'm in here creating this is pretty dumb about that. You can't like pull this thing down, get the action.yaml, and then tell me, hey, you need a Zeebe address. Coming soon, hopefully. Okay, so here's the second edition of the published Docker images. If we go back to Camunda operate, have a look at the dashboard. No data found for query not exist. So this here is, here we go, is the timeout. See, it timed out, and it raised an incident. So, in terms of like the semantics of this, what we can do here is instead of doing not exist to dummy, change this and say this here, build timed out. Build timed out. Set true to retry. Here we go. And I'll copy this and then make sure that it doesn't escape from this context. I'm hoping that that's what this does. Like that. And then redeploy it. And this is finished running, and yep. Okay, exit on configuration failure, and then push that. Go back to here. We can cancel this one. We go back to here. Build and publish completed. So, see, that's fast. That is fast. To build and push an image to Docker Hub is fast. Moving login credentials. So, if we go to Docker Hub now and have a look at these tags, and if I refresh this page, I should have showed you what it said before, but it'll be obvious anyway. Make it a bit bigger. Star it one up. Go down here. Here, last updated a minute ago. Very good. Very good. And we should now have a new incident in here. Okay. Oh, it didn't receive its message back. It's waiting on the subscription here. Okay, so if we go here and have a look at tell Camunda Cloud what's up, this will tell us about the message that it published. Okay, publish the message. Okay, however, the message did not get correlated with the workflow. So if we have a look at here, we're expecting GitHub event client payload.build ID to have a value. And it may not. I mean, I might be using the wrong context there. I don't think so, but what we'll do to make that easy to debug is if we go into main.ts where we do the publish operation, switch operation on publish message. So easiest way to do it is like this, const message payload, right? Grab this out. Going to make it easy for people to debug things that are not working as they expected. Okay, so this is message payload. And then let's just go like this to Camunda Cloud into Zeebe, because you could use this with your own hosted instance if you wanted, if you exposed the gRPC gateway. And then what we need to do here is we'll JSON stringify it. And we're going to stringify the message payload, no replacer, and 2 spaces indentation, and then let's rerun this thing here, rebuild it. And you know what? This is what we're going to do here. We're going to go npm install -d. I think, no, I don't know if it's the same as npm, but husky. And what Husky does is Husky puts Git hooks into your repo, so I can do a pre-commit hook. So if we go into package.json, we're going to create a pre-commit hook in here. I can do a pre-commit hook that will run this task. The only thing is the changed files, I don't know if I can automatically check them in, nor do I know if that's a good idea, right? But husky npm, let's just do this. Yeah, you can do lint staged, and then you can like lint them, reformat them on the staged files and add them, but this is going to create like modified files that weren't staged. There we go. Just add this in like this. Need that whole section there. So pre-commit hook here, we just go npm run rebuild. This will automatically run it, and then I guess the thing that would alert me to okay, so it doesn't like it because I just installed that new package, so control C, not overwrite. Close, do not save. Package.json open. Scripts, repository, keywords, we'll just whack in here. Husky. Commit hooks. Right, that's the cause of that. By now, the difference between pnpm and npm is that pnpm saves a single copy of the package on your file system that it can reuse between projects. So over time you build up like a repository cache. Well, let's test this out. So add husky. And the other thing that we're doing is we're print message. I don't know, log message. Like that. So, commit. It's pre-commit. Okay, well that's cool. Pre-commit's good. go to package.json, it should be pre-push actually. Pre-push. Yeah, because look at this, it's like dying like anything. I go into output and have a look at which one might it be. Any of these? Git. Nope. I don't get to see the. If you run git commit and git push in the terminal, you get to see what's actually happening. So if I jump out of here. Message came in, but it wasn't correlated, and then bam, we air it out. So if we have a look here, this will say let's go to incidents. Look at the incident here. Did we get the new one in time? No. So let's work on this. Ah, it's still running this thing. Yeah, this is not a good experience here because it's running this very long build process with no output to the user. It would be better to run this in GitHub itself. It would probably be faster too. I wonder if I can GitHub Actions commit changes. How does one commit from an action? Bash script. Now this action does what we want. Here we go. Push back to repository, e.g. updated code. Okay, you gotta do this. Do you see the love? See the love in your I could do this and it would rebuild it in the same kind of container that GitHub Actions run in, so I wouldn't need this complex Docker Compose thing. The only thing about it is that can I communicate? Let's have a look. VS Code. It's a GitHub action. Failure. I want to see if I can detect the failure in a GitHub action from VS Code because it's asynchronous, it's happening somewhere else. Like, I push my code, it's working, but maybe it's not. Expected. No, that was from the previous one. So yeah, this thing's still running in the background. No, this is a very bad experience. This is pretty bad. I can imagine myself checking this out and modifying it and then just thinking like something is really wrong. Required property is missing. Generate input template from object. Oh, including required properties and optional properties. Oh my goodness. Oh yes. Let's do it. So it's just what I was wanting. This is terrible. And there's no way to cancel the operation either. No, I can't have this. So I think we are going to do it inside GitHub. There we go. Oh, you need to put your GitHub token in there. Copy. There's a GitHub. It's got a test workflow. Okay, so jobs build, so we'll put it in here. So it runs npm run all. Let's look at all. Run build. Okay, so it does npm install, but we should do npm install. We don't need to do rebuild because there's no caching. But we'll build it on demand. Yep, does that, and we've got to put my GitHub token into the secrets for this repository for it to be able to commit back. Add changes from rebuild. Make sure the action works on a clean machine without building. Fail for sure. Hold.yaml. Okay, so put this in here like this. It runs on any branches, master, any release. You know what? Not just release, it should run on any branches, right? So it should just run on push. Get rid of the test step from here. Should actually run the test in here first. This is where the test would go. This should go there. I gotta put a GitHub token into the environment. So let me just comment this out. Okay, I gotta put a GitHub token into the environment of this thing. So that's in my Zeebe Action, right? So in Zeebe Action, we go to settings. Secrets, and new secret, and oh no, actually you don't. It gets the GitHub token automatically. Okay, so this GitHooks thing here, it's going to try to run the rebuild again if I do that, so I'm going to take that out for now. So we're going to lift this concern into GitHub itself. So save that, go here, we got this, and then I can't remember what the original change was. Rebuild and automate rebuilds. And push this to the remote. It goes. Okay, the Zeebe Action, if we go to Actions, they're both called build test. That's not very good. I'm going to change the name. This one should be just called build. Call it build push actually. Like that. Let's have a look and see how fast it runs on here. Is this even a good idea? I don't know. took me a while to get that Docker Compose local builder to work. Okay, that looks good. Let's see, compiling the file. It'll be interesting to see what it commits. So building this, it got the extension, it built it. No, it looks good. This looks much faster. Faster than running it locally. Wow. Way faster. Wait. If I go back to actions, is it going to go into a loop? Is it going to like trigger its own? No, it didn't. Okay, good. Okay, so it doesn't trigger its own rebuild. Okay, but this other build test failed. Let's have a look at this. What failed about this? Build. Push changes. Not lock it. Okay, so latest one wins. That makes sense. Changes. Okay, so in test. Okay, dude. Oh goodness. Check that out. Save that. And then change the name of build task job. Build job. No, workflow. Flow. Okay, so save that, push that, and then that will provoke the rebuild. Let me document this in the readme. Oh, okay. Pull some changes first. Okay, so get pulled. What changed? Package.json changed. Changed in here. Okay. Whatever. Push the changes. So, oh yeah, I should update the readme file. Readme development. Okay. Okay, the action is automatically rebuilt on Docker. Not Docker, is rebuilt on GitHub. By the, and then I can do like a link to it. So it's /GitHub/workflows. Workflows/build.yaml. To ensure that it has the correct. What are those things called? They're called binaries for gRPC. gRPC. Winning! Okay, so here we can go update readme. Okay, and push that to the remote. And then let's have a look at this. Okay. Actions. Push failed 1 minute ago. Let's have a look. What went wrong this time? Maybe same thing. Couldn't push to the remote. Commit. Yeah, couldn't commit. Oh, nothing to commit. Oh, that's interesting. Okay, how do I tell if there's nothing to commit? Interesting. Here we go. What happens if there are no changes? Start.js. Let's have a look. Okay. Start.sh must be in here. Yeah. push. Okay, so issues, 7 issues. Let's see if someone else has raised the default branch, push issue, error, set GitHub, interpolation of variables. 18 closed. Let's have a look. Push not triggering workflow, directory how to correctly set, failure error, gives failure error when no changes. This is it. Related to the example, so the problem is git commit if there's nothing to do, so changing the commit file step to only commit when there are changes. Okay, duplicate of 35 and 33 and 35 will fix it. Let's have a look. If this is 33, an option to not fail build if nothing is committed. So yes, use git commit echo nothing to update. Oh. Whatever. Okay, so let's have a look. I think I managed to achieve what I needed to do. I edited my, okay, so if we go here, we say, build, and if we go to git commit, changes here. Okay, so they reckon that if I copy this and put that in here, Control V, take that out, get rid of this here, and then okay, so make this say GitHub Action added changes from rebuild. Update my GitHub Action. Rebuild. Okay, so they reckon that that'll do it. So let's say handle no changes to commit. Go back to here and let's have a look at, this is the Minecraft, no, it's the Zeebe action here that I want to look at, so actions. Build test, build push. That's the one we want to see happening. Build step. Got the job. There we go. Yep, check it out. Run the npm install. Now, in the meantime, I think that my action's been updated so that if I now push to my Minecraft repository, it'll kick off another story. So okay, power is back up 1 level. Okay. Save that. And this time I'm just going to be straight up trigger workflow. Trigger workflow, save that, and then push. So, while this is doing its thing, commit files, this is where we want to see. There should be no changes? No changes. Yes, very good. Yeah, nothing happened. Good. Okay, so if I go back to my code. Yeah, good. Good. 29 commits. Yeah, there you go. Cool. It does. It adds changes from rebuilds. What does it push in? Okay. The difference here. I don't know. Let's see if it works. Here we go. Minecraft action. Docker images. Okay, so kickoff orchestration build happened. Publish Docker images is now happening. We go here to the dashboard. One instance one active instance. So let's get rid of this. This was at 4, that was half an hour ago. Get rid of it. Go back to the dashboard. We've got one running instance here. It's waiting for the message to be published back out and build and publish. Okay, so it's building the Docker image. Yep. And then publishing the Docker image. Yep, publishing. And it's going to tell Camunda Cloud what's up. And this is where we should see the message, the actual message payload get logged out to the console. Let's do it. Complete, pulling, download. 2 of 5. What actually happens in here? All from Docker as runtime. Okay. To build. Okay. Docker and Docker, hey? There we go. Look at that. Variables, build ID. We've got publish. It should have been correlated. If I refresh this, it get correlated. Did it get correlated? The value there. Tell Camunda Cloud what's up. Let's have a look. The build ID, the variables from the build ID. This is publishing a message. Yep, the message should get merged. Build ID. Ah, no, it's correlation key. Again, an error there. Yeah, message correlation is a little bit of a tricky one. So what we need here is not variables in the Docker image published, but not variables, but correlation key. And this correlation key is just simply this. This is how you do this. Like that. Okay, now it'll work. Okay, fix message correlation. Yes, here we go. Push that to Docker Hub. GitHub Actions. I think kick off orchestration. That'll run now. Kick off build orchestration as soon as my push works. Yep, that's going to start the Camunda Cloud workflow. Oh, looks like my cloud cluster is being rescheduled right now. Oh, yeah. How do you deal with that? Okay, publishing the Docker images. Okay. Now, running instances, there are 2 of them. So this one was at 28, so cancel this one. Look at my running instances. This is the latest one here. The other one's been cancelled. So we're now waiting for the base image rebuild to finish. Okay, looking good. Build and publish. Publish Docker image to repository. Camunda Cloud, what's up? This is awesome. Wednesday. Yes. Working directory on the server. Okay, publishing the message. There's the correlation key. That should the name and the correlation key is enough to target this workflow. Boom. It's moved on to there. Oh. Yeah, that should publish this message here. So if I go to the JWolf Camunda Cloud publisher, right? Zeebe Action. Okay, so if I go to jwolf, Camunda Cloud, message publisher, and if I have a look in actions, I should see that the workflow got yesterday nothing. Okay. Did not get triggered. This looks like it's stuck on that point there. Shouldn't be though. Okay, so look at this. We got a build ID, GitHub token, status code 204, which is from this previous one. Have a look at the modeler. Here, this is a Camunda HTTP. We got publishes it to repos, jwolf, Camunda Cloud, message, publish, dispatch it. It's got body, input, output. We didn't do the authorization header. That's why it's not going to get any authorization. So we've got an authorization here. Authorization. No, that's the target. So that comes off GitHub token. Not even GitHub token because it's bare a GitHub token, but whatever. Should have called it GitHub auth or something. That's why I made the mistake of just putting the token in naked before. I'm surprised that I'm not getting a response back saying like failed, you know, like maybe if I refresh, I'll get an incident saying, you know, got a, no. Why did this not fail? It's a Camunda HTTP task. That's why it's Camunda-HTTP. There's a second mistake there. Wow. Cancel this workflow. Go back to my GitHub CC thing. Window, GitHub CC, GitHub Camunda Cloud, redeploy the Boy, now I need to go to my Minecraft one. I need to provoke another change, right? So, okay. Automated builds. So this repository. Automatically rebuilds the images and pushes them to Docker Hub. Pushes them to Docker Hub. 2 words. Via a GitHub workflow. Save that. Update README. And push. Okay, so let me just double check. Yep, version 6. Okay, so if we go to the dashboard, if we go to the Minecraft repo and have a look at the actions, what's happening, is it running, publish Docker images, kick off build orchestration. So that's running now. It's pulling out my Zeebe action, publishing a message. It's taking it so long. Start the workflow, one completed job. So created a Zeebe workflow. Details. You can actually create a workflow and await the outcome in a GitHub action. Or you can take this workflow key, assign it to an output, and then pass it into the next, into a later step. Okay, we'll go back to actions. We should see publish running. Yep. Publish is now running. we have one running instance of the workflow in here, which will now be waiting on the built images message subscription. There we go. It's waiting for the base image rebuilt message to come in. So if we go back to here and we look at build and publish, and then once this publish Docker image to registry is complete, it's going to publish the message to Camunda Cloud to tell it it's finished. Strongly typed BPMN, man, that's what we need. I saw a paper about it earlier today. But let's do this. Let's get strong typing for these GitHub Actions and see if we can auto-complete my action. That'd be awesome. Make changes as necessary. Oh, this is for development. This is not for installation. Like, how do you YAML via YAML language service? It's a YAML extension, okay, but is there a built version in here? Well, you know what? Maybe it's in releases in the code. Let's have a look. Issues, 2 issues. Let's have a look. Overly restrictive regex pattern for working directory. False positive if matrix entries list of objects. Good to know. Remove overly restrictive. Okay, so there's a pull request in there which was opened on the 3rd of Jan, so no updates since then. Let's go to code and then releases. There are no releases, so how do you actually install it? New version extension. How to run and debug the extension. Okay, well, it's called GitHub Actions YAML extension. Maybe it's available in the marketplace. Did look the other day. What does this do? Oh no, okay, it's not GitHub Workflows. That's why they called it GitHub Actions actually, because GitHub Workflows has already been taken for like Git flow type stuff. Here it is, GitHub Actions. YAML extension. Oh, install. Okay, there is a GitHub Actions. Oh, this is great. I'm writing a blog post about this, and in there I said there's no extension support for it, for like validation of schema. I was wrong. And it's installed. Okay, well, let's have a look at this build thing here. Let's have a look at another one, which uses the Zeebe one. Good. Okay, report result. No, a different one. Oh, Minecraft uses it for sure. And push right here. Okay, so if I now go Control P and say reload window, reload it with the extension loaded, and then I should be able to do something like this. I'm not seeing an error like I'm missing a required runs on. Do I need to run? Save? Nope. Let's go back and check what was happening over here. Build and publish. Tell Camunda Cloud what's up. So it published it. It's got the correlation key. Let's go back here. Refresh. What happened? Should have raised the incident. Yes. Good. This one has completely run through. It published that message and then it finished. And then it started another instance of the same process, but from a different point. Right there. Beautiful. Works. So we're able to trigger workflows in GitHub from Camunda Cloud. So here's what we've been able to do. We've been able to start a workflow in Camunda Cloud from a GitHub action on a Git push. We were then able to trigger a GitHub action / workflow in a repo from the Camunda Cloud workflow. We were able to then communicate back from that, dependent workflow back to Camunda Cloud and then continue. And then here we're about to trigger another workflow from that. So now you can see we have pretty much all the basics that we need to be able to trigger, and do a complete section here. The only thing, and this is why I'm like in my head right now thinking, is not clear yet that we have the ability to communicate back from the GitHub workflow failure. So when we trigger a dependent workflow, at the moment we can communicate success back, but I don't know if we can communicate failure back to the workflow. But this is very good. This is very good. We've got all the basics for the happy flow, at least. To be able to fuse together multiple repos, and then have like dependent repos, the relationship between dependent repos expressed in a BPMN diagram rather than, spread out in the YAML of the various repos. So this is a very powerful orchestration tool for multi-repo builds, dependent repos. Winning. Okay, I'm going to call it a day for the stream today. Thanks for tuning in and checking